So, ladies and gentlemen, welcome to the second conference day. Hopefully you can hear me well. Okay, could you type in the chat if everything's all right? Okay. Yes, very good, very good. So we are starting the program today. You can see it on the screen, right? And today we have full two sections, yeah, actually, 2 parts. And there is no special focus or subject focus, just different sorts of papers. Just unfortunately before the conference, I heard that one paper unfortunately is canceled by Simon Litwin. It's a pity, of course, but there are some circumstances that he could not overcome. So we'll have either 1 hour break, and we also can keep a meeting going so people can communicate with each other. All right, so let us move ahead. I guess you have no questions. If you have any questions, again, it's different from yesterday. Now we are working in a meeting mode rather than the webinar mode, which means everyone can see everyone else, and you can also communicate with each other. In a chat window, you actually could choose whom you send your message. Either you have to everyone, or you can choose any name to send a message to that particular name. You see, there is no panelists anymore. Everybody is equal. I'm just the host of this event. And also, please keep your microphones on, because in this mode, we all can show our screens, our videos, and our microphones. Okay, so let us move ahead. And the first presentation is by Karl Zhang and Zhuang, which is called Pattern Circumvention and Strengthening in a Wind Turbine Blade Noise Reduction. Well, I see Karl Zhang is here, so you can take the screen. If you don't know how to do it, you have in the bottom of your screen, you have share screen button. And also you have to unmute your microphone and you can present. Very good. Please move ahead.
All right. Could you see my screen?
Yes, everything's fine.
Okay. Hello, everybody. I'm Karl from Beijing, China. And I worked for a big wind turbine company. Today, my presentation is about pattern circulation and strengthening. Perhaps you know when the wind turbine is running, the blade will generate a lot of sound, especially at the trailing edge at downstroke stage. You can see in this picture, the red indicates the loudest noise. If you get close to one turbine, you can hear it clearly. So different countries formulate regulation to control the noise level. Here, I want to make it more clear how the noise is produced. We can see at this picture. When the air flows around the surface of the blade, it will arouse turbulent. It will allow turbulent fluctuation. And the turbulent, when the turbulence slide off the trailing edge, then the noise is produced. Normally, some add-ons are used like this shape. They are glued to the trailing edge of the blade. When the turbulence flow through the add-ons, it can scatter the turbulence, so the noise can be reduced. And the method for and the patent for this method has expired, so we can use this method for free. But last year, a competitor's patent caught our attention. It adds more details to the normal add-ons. We can call it serrations. There are some more details, and it claims that it can further reduce the noise. So we decided to take some action. First, we read the independent claim from the competitor patent, and the patent number are shown here. Through the independent claim, we should select what components are contained in it. So we identified all the components, and the rows are the same as we learned in the function analysis. Next, according to the independent claim, we built the function model. Here we can see the component mentioned in the independent claim are contained in our model. And of course, for our convenience, we can select some system component altogether. When we are doing pattern circumvention, in fact, we don't need to consider whether the function is harmful, insufficient, or excessive, because that's not our aim to solve it. But here, I show the harmful function. So when we are performing pattern circumvention, trimming is the first tool that we can use. Here, we can see there are only three components: serration, component, and the ridge. And of course, the function are described in the patent. We can easily add it to our model. Serration are used to diffuse airflow. Cone element and the ridges are also used to scatter the airflow further, so the turbulence will be lowered and the noise is also lower. Because there are only three elements, what components should be trimmed? Serrations are one part of normal design, so it's very difficult to trim. Here, we first choose ridge as our target to trim. The function of the trim is to scatter the airflow. If we trim the ridge, how to remain is use function. According to trimming rule C, we can select another component to perform its use function. How about serration? Serration is a flat plate. How can a flat plate to perform scattering airflow? Here we think an idea. We didn't use the ridge, but we use the graphs. When the airflow flows through the graph will also separate the airflow apart. So it can also perform the same action to scatter the airflow. That means we delegate the function to the component serration. Also, we can try trimming rule B. That means how can airflow itself perform the function scatter itself? It's a new question we created by trimming, and any other people have never thought about it. How to realize it? We can see through this picture. The blade contained suction side and the pressure side, and the turbulence are mainly on the suction side. So how to scatter the turbulence on the suction side? By airflow itself. We didn't use the ridge. Instead, we use the airflow itself. We can make the through hole at the same place as the ridge. So when the airflow go around the surface of the blade, the air on the pressure side will go up to the suction side. It will create air ridge. So the air itself will separate itself. Here we successfully use trimming rule C. We delegate its use function to the airflow itself. Next, also, when we are doing pattern circumvention project, there are some attributes mentioned in the independent claim, like in some place, in what place, in what direction, or what shape. So we analyze the attribute in the independent claim. It said that the serration are flat and along trailing edge. If we change the attribute, whether we can get another good things. Also for common elements and ridges, we list all the attributes mentioned in the independent claim. We take serration, for example. In the independent claim, it said that the serration should be flat. We know in the detailed description of the patent, the serration should be flat in order to adhere to the blade easily. But we can easily think that if the serration be curved, it will withstand bending stress better. So here we get physical contradiction. By attribute analysis, we formulate physical contradiction. How to solve it? Of course, we can use a separation, a different separation method. Here we applied separation in space. What space? The serration should be flat, and what space the serration should be curved. In order to adhere to the blade easily, the upside of the serration should be flat, and in order to withstand bigger stress, the lower part should be curved. So we, by this way, we change the attribute of some component. Maybe the solution is patentable. The next part is about also another physical contradiction. Common element should be in clockwise direction to reduce noise efficiently, and the common element should be downward against clockwise direction for increasing the lifting force. Again, we use the separation in space here. What space should be in clockwise direction, and what space should be in downward direction. And we generate idea shown here. And the next part is about how to strengthen our own solution, or how to build our own fence in order to prevent others to circumvent our own patent. Without doubt, trains are the best tools. We learned different trains in my TRIZfest level 3 training. Here, I applied one of the trains tradition to the super system. There are 4 substrains in this slide. I think everybody know it very well. By this trend, we try to add more details to our node solution. First, the first substrand said that parameters of the integrating system become increasingly different from those of the engineering system. In the initial solution, all the tools are of the same size, of the same shape. How about change the shape and the size? So here we get the tools with different shape. Maybe it will generate good things, maybe not. And next, the level of integration between the engineering system and the integrating system become deeper. There are big tools and smaller tools. How to combine them together? This is one type of this idea. So according to this solution, we searched and also patent it. So we add more details to our original solution. This is our fence. I think it can strengthen our solution. Of course, there are other trends, but they are not mentioned here. Next, we also use MPV identification to identify what features, what functions can be added to our system. First, we also built the function model in its usage stage. Here, we didn't consider how to reduce the noise. The add-ons, the serrations panel is glued to the trailing edge. So after several years, it will evidently drop. So one problem is how to solve it. When it falls, it may damage objects around, even hurt people. This is a function model. We can see blade hold the serration path. The function is insufficient. Also, air decelerate serration path. The function is also insufficient. Then we ask why, and build the cause-effect chain analysis model. We think it's very difficult to solve how to glue the serration path firmly. is very difficult. But we think in another way, where the wind resistance is small. So how to increase the wind resistance? According to this key disadvantage, in order to increase the wind resistance, we should change the shape of the add-ons. One easy way is to change the center of gravity. It's the original design, and the new design, is that the center of gravity is moved to one side, so it will swirls as it falls, so its dropping speed will be lower. And we test one of our solution. The solution with multiple small tools TESE in this way. And line 1 shows the blade without any end-ons, and line 2 indicate the blade with initial design of serration. And the bottom line represents our new design. So we can see that the noise reduction is very effective. It proves that it does work well. Yes, this line indicates our new design effect. Okay, in the end, I want to say thank you to Sergey and Alex. They did give me a lot of help in my project. Okay, that's all. I'm glad to answer any questions if you have. Okay, thank you.
All right, Mr. Zhang, thank you very much for your rather interesting presentation, because you showed the whole array of tools, and the results were rather interesting, I believe. Yeah.
Mm-hmm.
So, ladies and gentlemen, if you have any questions to Mr. Karl, now again, you can type your questions just to a general chat. Just my question, maybe I a little bit missed, maybe interesting. Those windmills and blades, they are used on the land, or it is for offshore applications, or you can use your patent in both? Mr. Zhang, did you hear my question? Hello?
There's no question.
Yeah, can you hear my question, which I'm asking? Your invention, is it better used for land applications or offshore applications?
Yes, it's better than the old design. Mm-hmm. It does work well. Mm-hmm. And some of the solutions are testing in this time. So whether other solutions are effective, we can't come to conclusion yet.
Mm-hmm. Okay. Thank you very much. So
okay,
any other questions? Yeah. I see no questions coming. Your presentation was very clear. So, Mr. Zhuang,
Okay.
thank you very much. Thank you.
You.